Good day, everybody. Welcome to the presentation on KNX Energy Management with KNX Classic and KNX IoT, and also explaining the relation of this energy management to the PR EN50491-12-2. My name is Joost Dummerest. I'm the CTO here at KNX, and again, a warm welcome. The second slide of my presentation shows what I have in store for you. So I will start off with what exactly is meant with the word energy management. Secondly, energy management, is this an application that KNX can cover today, in the future? Well, to already unveil a little bit, of course, KNX can already manage this very well today. We can even cover several types of energy management applications. I will show you briefly which ones we can cover. And then I will switch to the PR EN50491-12-2 standard. KNX is helping out on the development of this standard. So what relation does this standard have to the previously shown energy management applications? I will then try to explain you what kind of energy management functions can be realized with this standard. Then I will explain you how can KNX realize the functions that are described in this standard. Would communication be more appropriate with group communication? Would it be more appropriate with property communication? Or is this something which we really should target for KNX IoT? And then I will round off with an overview slide showing how everything will work together. So KNX IoT and KNX Classic and energy management. So let's get started. The term energy management is a very broad term, a term that is often heard, and there is a lot of confusion on what the content is. To start off my presentation, I thought, why not look at how Wikipedia defines the term energy management? And I read out what Wikipedia says there. Energy management includes the planning and operation of energy production and energy consumption units, as well as energy distribution and storage. The objectives are resource conservation, climate protection, and cost savings, while the users have permanent access to the energy they need. So it's all about trying to get energy production and energy consumption in sync, but taking care that the user has no disadvantage of that. Also with the goal, well, to actually save energy, not waste energy, and to reduce costs. I think, yeah, energy management is a thing that really happens within the home or the building. So it's a thing that happens behind the distribution board, and tries to manage the applications that are behind the distribution board, all also with the idea to help the grid being smart. If the grid does not produce sufficient energy for all the homes to be able to be fed with energy, then the home or the smart home will help the grid to stabilize its energy provisions. Okay, well, the first question is, if it's all about energy management, does KNX help in realizing energy management applications? Well, the answer is a clearly yes. KNX has been active in this domain for many, many years. I would even say for some of the applications that I will show in the next slides, KNX has already been around with these applications since the 90s even. So for instance, can KNX control heating production? Yes, it can. It has been doing that. Many major brands offer units that help to control heating production. In the late 90s, beginning of 2000s, Many units were put on the market that also allowed to monitor and to also control air conditioning and also later on heat pumps. So here you see a specific example of units that help monitor well-known brands of air conditioning units and heat pumps. I also draw your attention that all the products that are shown here in the presentation, they are just examples. There are many others around that you could use just as well. As far as the individual room control is concerned, so regulating the heating consumption and the cooling consumption in a room, so not an entire building or an entire home, that is one of the application domains where KNX has been very successful in recent years and even since it was put on the market in the early 90s. In the more recent years, there are also products on the market that allow you to connect the KNX system to metering and or sub-metering. So metering of parts of the installation, or I will show you in the next slide, even up to the level of the electrical circuit. So this example of one of our members allows to measure the active and reactive energy. It allows to measure the power per phase and also the overall power consumed. As regards load management, so ensuring that the level of the loads stay within certain set boundaries. Even as early as the 90s, there were products in the market that allowed you to make load management. This example even allowed you to address up to 120 different loads via KNX. You could define different priorities for that. You could ask the device to send you statistics. So quite an elaborate functionality that this product already had back in the 90s. I announced you in the previous slide that there are products around that allow you to monitor your energy consumption for parts of the installation, sub-metering, but there are also products on the market that allow you to monitor your energy consumption even up to the level of the individual circuit. So this product allows you to monitor up to 3 different circuits and also allows you to limit the power consumption to a predefined level. There's been a lot of talk about, at least in Belgium, where the KNX headquarters are located, there's a lot of talk about replacing the analog meters by digital smart meters. This product is an example of a product that allows you to connect the digital smart meter in Belgium or in Holland to KNX. This example is for single or 3-phase meters. Import and export of active power per phase is possible. So also the measurement of your own PV production, the current and the voltage per phase, the active energy for 2 tariffs. And so all of that, you can connect your digital smart meter and actually forward this information onto KNX. You can, with simple binary outputs with potential free contacts, you can integrate all different kinds of loads into an energy management system based on KNX. So you can control, for instance, a charging station of an e-car and switch it from full to reduced power or back. You can connect a heat pump via the smart grid contact. You can boost domestic hot water production, etc., etc., etc. So this allows you to integrate just any kind of loads. Okay, recently also KNX has it being extended towards application domains that were previously not covered by it. Totally new application domains because of the fact that, they didn't exist before long. these are also application domains that are expected to grow a lot in the near future. The first thing is energy storage monitoring. This is now also possible with KNX. We have a energy storage manufacturer that has recently become member of KNX and has a module that allows to transport information on the energy storage onto KNX. And also recently, for connecting charging stations to KNX, there is a company that has released a product to the market that you can see right here, and that allows to connect quite a number of different charging station brands to KNX via an integrated Modbus RS485 interface. Here the features that are offered by this product are shown. So you can show whether a charging station is occupied or free. You can show the charging progress on KNX, for instance, on a panel. You can set the charging time and limit the charging power depending on load tariffs or own production or consumption. The module can report errors. It can show the overall energy consumption. It can show the last charge, and it offers support for KNX Secure. So on one slide, all these applications put together. So with KNX Classic, you can already cover a lot of energy management applications, sub-metering, peak shaving, batteries or storage systems, PV systems, e-charging, smart meter, heat pumps, and traditional HVAC applications. How is this energy management actually realized? I've already shown you quite a number of products. Either this energy management is done at device level, or it is done in a visualization software, or it is realized in a central panel unit, allowing advanced logic operations like the one shown here, or it is realized in a separate home or building server, or it is realized in a combination of all of this. Actually, I always compare KNX to Lego bricks. So you can put the Lego bricks together much to your own needs. Of course, all of this can be made accessible or controllable via internet. And you can put this information you get from these products, or you can control these products via appropriate apps. All of these tailor-made energy management solutions can be provided to you by a competent, skilled KNX partner, of which there are about 100,000 on this planet. So you will definitely find a competent partner for your home or your building. I already told in the beginning when showing you the agenda of my presentation that there is a new standard being made at this point in time. This is the EN50491-12-2. Actually, the architecture of this standard, which deals with energy management, is laid down in the part 1. So 12-1 is the architecture, 12-2 is the actual standard. So the system architecture was already made a standard in 2018. And I have tried to explain this architecture by means of this small picture. The standard is all about the interaction between a SEM and RMs. SEM being a customer energy manager and an RM being a resource manager. So the resource managers, they are there to abstract the home and building electronic systems towards the energy manager. as regards energy needs or energy offer. So what does this mean? This means that the resource manager is a way to make the energy need of this, what is behind, more abstract. So the HBS, this HBS could be a single device, it could be multiple devices, or it can even be an entire system. So an entire HVAC system could be abstracted by a single resource manager. So this would mean that not all technical details of all products would be visible to the energy manager. Only the so-called energy flexibilities of an entire system would be shown towards should be visible for this customer energy manager. The information that is exchanged between the resource managers and the SAM is standardized, but the protocol on which this information is transported is not standardized. So the S2 simply standardizes the information exchanged, not the protocol. The S1 interface, so the connection of the energy manager towards the grid, is not standardized, so it's not part of this standard 50491-12-2. This is out of scope because it is found that this interface is standardized by other groups in standardization than the group dealing with this 5491 series. This is Senelec TC205. Yes, I maybe forgot to tell you, I always compare this architecture with an orchestra. So the director of this orchestra is the energy manager, and the musicians are the resource managers. So a musician can only start playing when the director tells him to do so. Okay, so in this standard, there are a number of control strategies that are defined, which are called control types. There are 5 different control types defined. All of them individually are intended for different purposes for realizing energy management between a resource manager and a SAM. The first control type that is defined is called the power envelope based control. I have always included a snapshot of the standard in my slides to make the control types better understandable. The first control type, the power envelope based control, you could actually compare that to a speed limit. The SAM will ask the resource manager to stay within certain limits. So here you see that the SAM will ask the device or the system to stay between different limits, an upper limit and a lower limit. And as you can see in this diagram, these values can change over time. So you can imagine, for instance, a heat pump where the SAM will ask that it, for instance, wants to produce less energy. So the SAM will adjust the power envelope to the power forecast that is given by the resource manager. So the heat pump will actually make a power forecast. And this power forecast can be a single value, or it can be a minimum, maximum, or even a range. When the SAM has imposed a certain speed limit, then the resource manager or the device must again react with an updated power forecast. This is the first control type defined in the standard. So I will switch now to the second defined control type. This is intended for different types of devices. And a typical example of a device that is more suitable for this kind of control type is a washing machine. Actually, the device will inform about when it wants to start and when it wants to be finished. So as you can see here from this snapshot again, it will inform about its start time, be it 5 o'clock in the evening, and when it would wish that the whole program is finished by 9 o'clock in the evening. So the device will inform about the different phases of the whole process. These phases are called the power sequence containers. And the device will inform about the different options inside such a container, and the different options that can be selected by the customer energy manager. The start of such a container can be delayed, however, only for a maximum indicated time. As you can see here, the first container has a max pause before of 0 seconds, but the second container has a pause for of 10 minutes. And also a power sequence can tell whether it may be interrupted or it may not be interrupted. Such, for instance, if you look at a washing machine, some parts of the program may not be interrupted. So it's not possible to actually stop some of the processes in the washing process. The third control type is the operation mode based control. Again, this control type is for yet other types of devices. So you can think of a diesel generator, for instance. A diesel generator, for instance, can be abstracted as having, for instance, 3 different operation modes. So the first operation mode could be the one where the diesel generator is completely off. A second operation mode could be where the diesel that generator could be run at reduced power, and you could have where the generator would be operated at full throttle, so where it actually produces the full power it can. Between these operation modes, there are transitions. And these transitions are also, you need to take into account certain timing aspects. So you cannot simply switch from one mode to another. There are some timers that you need to take into account. Each of these modes have a certain power, but this could be a single value, but this could be also an allowed range. So the SAM, so the energy manager, is informed about these device parameters in advance, so that it can make realistic plans on energy production or energy consumption. So the SAM will, at a certain point in time, tell to the device, okay, I want you now to switch from one mode to another, and I want you to actually start this mode from a certain point in time. The fourth control category is the so-called fill rate based control. Again, this control type is yet for another type of device. This is especially intended for devices that can store or buffer energy. So a battery storage is a typical example of a device that would be controlled via this control type. So the device can inform about how full it is or how empty it is. So it informs about the current fill level, and it informs about the boundaries of its buffer. The boundary can never be beyond a certain level, and it can never be above a certain maximum. The device will also inform about its leakage behavior. If you think of, for instance, a boiler, of course, if you don't put more energy into it at a certain point in time, the warm water will be again cold. And the device will be able to also tell you about how fast the heat will disappear from its storage. If you want the heat not to disappear from this storage, you will have to, of course, add heat to this storage, and you will be able to add heat to the storage. You could do so by different means. So you could do this by, for instance, a heat pump or a heating coil. So this is abstracted by so-called actuators. These actuators actually tell you how you can effect this buffer on the basis of this information supplied by the device. The SEM can send instructions to the device indicating the desired running mode of the actuator and the desired time of the transition. And last but not least, you can have devices that are flexible in the type of energy they can use, but they are not flexible in the way they can store or buffer energy. Actually, they cannot store or buffer energy. The energy that is produced must be consumed right away. For instance, this type of devices is, for instance, a hybrid heat pump, which can produce energy, and it can produce energy by the fact that it has a way to produce energy by electricity or by gas. So the device informs about the demand rate, and this can be a single value or a range. The device can also provide a forecast of the average demand rate in the near future. And the operation mode of the actuators indicate how much can be produced in that particular mode. And then the SEM needs to find a combination of the operation mode of the actuators that fulfills the demand rate. So we have a certain demand, and the SEM must then regulate how much energy you will consume to actually fulfill this demand. How would this EN50490 be realized, or this 5491 be realized by KNX? As you have seen from my presentation, the needed data structures that are exchanged between the SEM and the resource manager mostly relate to changing device parameters. So device parameters that change over time. And all of these structures are nested structures. These data structures are quite elaborate. So for typical group communication with 14 bytes of information, this will not be possible. So we will have to use extended frames to exchange this information between a resource manager and a SEM. But typically, this information goes from a resource manager to the SEM, and from the SEM back to a resource manager, or maybe in some cases from a SEM to multiple resource managers. So it's not typical group communication, it's more like one-to-one communication. So actually this communication would be more appropriate for object and property communication, maybe even it would be more appropriate to use function properties for that. But of course, typically the electrical contractor binds group objects to one another. Electrical installer will typically not link different devices together. He links different group objects together. So he does not know the concept of actually linking devices to devices. This would mean that the future KNX IoT point API, where there is a possibility to translate these structures in JSON format, and where devices to devices communicate rather than group objects to group objects, would be more appropriate. Maybe in the future we will see two types of communication: device to device communication, and event-driven communication would still use classic KNX. This last slide shows you a full-fledged KNX installation where I have depicted the known world of today, where applications still exchange information pretty much in the way we know today. So an energy actuator will still continue to send group messages with momentary values of the devices, which can be displayed on a display unit, in which a customer energy manager could be realized. But if you look at the EN50491 standard and a full-fledged energy storage system, this information would be exchanged via the new IoT mechanisms, via more elaborate JSON structures to also the same SEM device. All of this could, via IoT, be connected even to the cloud, via an edge device, or even via the third-party API. And this whole system could be linked to the classic system via a KNX IoT gateway. Okay, that completes the presentation on energy management with classic KNX and with the future KNX IoT. Thank you very much for attending this session. I hope it was interesting.